I'm very proud to announce a new product to our aerospace division. This is a conductive coating. What is a conductive coating on airplanes? These are applied strategically depending on the model of aircraft. On the radome, for example, wing-to-body fairings, some miscellaneous areas. It's all on the AMM, it's all on drawing. It will tell you exactly where to place these materials. This one is a 1-to-1 ratio. Of course, it's black, being a conductive coating. It can be used with any spray equipment, comes to mind, not ESTAT. This is conventional spray equipment. Once this material is dry, any primer top coat system may be applied on top of this material. This is strategically placed on aircraft, and it could vary by make, model. Different areas are applied in conductive coating. Must or usually goes on top of a primer, on top of a surface, on top of something, and it's usually a composite material. The application of this is one singular, one cross coat, depending on how you apply this. It doesn't have to fully hide. It has to be insular to the background itself for closed film. And then you can apply a very thin coat of primer on top of that to tone down the black, or go straight to top coat depending on what the top coat color is. So I'm going to be mixing this and apply it over the primer. Okay, top tip, mixing. Again, it's very important that if you're scooping out the can, you keep the lid clean. Make sure that the channel's right so you can press down for future use. If you leave the lid open, the shelf life, obviously solvents evaporate, it leads to debris in the can. What we normally do is we take a relevant sized clear glass beaker, and I pre-mark them essentially, and this for accurate mixing. What I'm going to be doing in this case, I'm going to be scooping with a cup. Make sure it's the non-wax design so that it doesn't melt and disrupt the finish. So we're going to just take the cup here. Okay, we're now 200 mils in this case. And on this big mouth can, which is generally very easy to pour out, we're going to dispense. And the reason I do this is to keep everything clean. Decanting into a small one into the container is better than trying to slosh into this, particularly when you're doing parts of a gallon. So it's to keep things clean, emphasizing, guys, the kitchen is everything. If you get this wrong, then it falls down from there. So here we are. We're now at a 1-to-1 ratio. The material is very thin. As we can see, everything is stirred and stirred well, pre-shaken base, obviously. So it's very, very thin. This is a working product. So once you've got a nice dispersion here, you can feel it actually on the stick when it's all one. We'll place it into the PPS. And then dispose of anything that is of no value now. Again, if you're doing components, what I would encourage, that you write the mixing time, the activation time down. That's when you know it's still in pot life. Good, it has a good pot life. You still need to know, if you're in a production shop doing various components, you're not sure when you mixed it, so you have to remix when it could be in pot life. Again, back on the can, we'll use a composite mallet there just to squish it down into the rim of the can. And again, that maximizes shelf life. As for the gun's concerned, again, conventional gun, typically, the area is very strategic on aircraft. The areas can be confined to radome body fairings, certain areas of the aircraft which are specific for that frame. And as mentioned earlier, it can be in the AMM or it can be on drawing, a schematic drawing. And that will tell you where to apply this material. So here we are, and let's get going.